Okay, so in this video we're going to look at the digital IC chips and look at how the layout of the chips work and how to install them and wire to them. So the digital IC chips are what we use for our digital circuits. So IC just stands for integrated circuit. So that just means everything's all packaged together. So, in some of your other classes, you have to build component by component to achieve the circuit that you need. Well, here everything is all packaged together. So to start with, I'll just show you here one of the IC chips, okay? And this is the inverter chip. And I know that because it says on there 7404. Now there's several other letters there that the manufacturer includes and numbers, but 74 and 04 there tells me that this is the inverter chip. Okay, so be careful when handling these. So you can see the pins here on the bottom that go into your circuit board or breadboard. They're very sharp and can easily prick you, so be careful of that. One other thing here is to note right here at the top this little cutout indentation in the chip, and that little notch there indicates the top of the chip, and that's important in identifying that for purposes of numbering, so we know where to connect things on the chip. So there's not actual numbers stamped on the chip, so you know what's what. So we use that notch to indicate where the numbering starts, and we'll look at that in the schematics in just a little bit. Okay, so when we install this on our breadboard, we need to place it here in the center across this gap. Alright, so the breadboard, as you should probably already know, they're connected across in rows of 5 pins on each side. So this top row of 5 are all connected together, and this top row of 5 are all connected together. Now they're separated along this way, but across they are connected. So that means we can't put this in over here, for example, because that would short out the pins on the left side with the pins on the right side, and it wouldn't work. So we need to put it across that gap so that we isolate one side from another. Okay, so when installing that, just inspect the pins first. Be sure none of them are broken off or bent, because if that's the case, it won't connect down in the breadboard and your circuit will not work. So just make sure you get those aligned up where you want it to be, and then just push it in. You might have to adjust the chip a little bit to make it go in, and then push it all the way down till it's connected like that. Okay, so it's completely down on the chip on the breadboard, and the notch is at the top so that we know where to connect things using our schematic sheet. Okay, so now let's look at that. So here we have the schematics for the chips that we'll be using in lab. So all of these are the 7400 series, which is TTL logic. And so the first one, the one I showed you in the example here, was a 7404. So that is the inverter chip. Then we have the 7408, which is the AND chip. The 7432, which is the OR. The 7400, which is our NANDs. The 7402, which is our NOR. And the 7486, which is our exclusive OR. Okay, and those we'll be using most often for our different lab situations. Now we have some others that we'll be using a little later in the semester. We have the 7411, which is a 3 input AND, 7474, which is a D flip-flop circuit, and a 74112, which is a JK flip-flop circuit. Okay, but all of these numbers associate with the different chips and gates that are associated with them. So depending on what type of logic you're trying to achieve, you'll have to make sure you pick the right chip number that is stamped on that IC chip. Alright, so again, looking at these schematics, I talked before about the notch. Okay, so that indicates the top of the chip. So the first pin to the left of that notch is always going to be pin 1. Okay, so you can see that on every single one of these. The first pin on the left is pin 1, and then the numbering just goes straight down to 7, and then it wraps around. So it does not start over at the top, it always wraps around. So here's pin 8 up through 14. Okay, so that format wraps around on every single one of these. Okay, so that's the next important thing to know. All right, then after that, we need to make sure that we are aware of the power connections. All right, so along with our inputs and outputs that we connect to our actual gates, we have to power up the chips as well in order for them to work. So pin 7 down here connects to ground, and pin 14 up here on the top right connects to VCC, which is our positive 5 volts. Okay, so bottom left, top right, that's your power connections. Again, that format is the same on every single one of these. Bottom left, top right. Okay, now this 112 chip's a little different. Instead of it being 7 and 14, it's actually 8 and 16, because this is a 16 pin chip versus the rest of them, which is only a 14. But still, it's still bottom left, top right is our power connection. So you always want to make sure you wire that first before you get started. Okay, so once you've established that, then you can look at the wiring for the individual gates. So every IC chip has multiple logic gates within it. So if you need 4 inverters, for example, to build a circuit, you don't need to get 4 7404 chips to do that, because I have 6 inverters inside this one chip. So I can use one to build what I need. Alright, so the way this is laid out is pin 1 goes to our input, pin 2 is our output. Then for the second inverter, 3 is our input, 4 is our output. Then for the third one, 5 is the input, 6 is the output. And then over on the other side, 9 is my input, 8 is my output, 11 is my input, 10 is my output, 13 is my input, and 12 is my output. Okay, so next we have the 7408, which is our 2 input AND gate. And so there's 4 of those available. Okay, and the layout for it goes as 1 and 2 is our inputs, and pin 3 is the output. And then for our second one, we have 4 and 5 is the input, 6 is the output. On the other side, we have 9 and 10 is the input, and 8 is the output. 12 and 13 is the input, and pin 11 is the output. Okay, so you have 4 AND gates available in the 08. Then we have the 7432, which is our OR chip, which has 4 OR gates available, and the pin layout is exactly the same as the 08. So 1 and 2 is the input, 3 is the output. Same goes for the second one, third and fourth over on this side. Okay, so the layout is exactly the same. Down here, our 7400, which is the NAND gate. Again, 4 of those available, and the pin layout is the same. 1, 2 is the input, 3 is the output. So the pin layout for the 7400 is the same as the 08 and the 32. Alright, then we get to the 7402, and they swap it for whatever reason. Don't know why. But here, 2 and 3 are the inputs, and pin 1 is the output. So everything's backwards on this one. Here, pin 4 is the output, 5 and 6 are the input. Same with the ones on this side. Okay, it's reversed. Don't know why. That's the way it is. Don't let it mess you up. Alright, the next one's 7486. Now it's like the 08 and 32. 1 and 2 is the input, 3 is the output. So this is our exclusive OR. Again, 4 of those available. Alright, and then down here we have our 3 input ANDs. So later on we'll do a couple of labs where we need a 3 input AND. So we'll use this chip. And the connections are a little bit different. So if you look at this one, so for this first AND you have pins 1, 2, and 13 is the input, and pin 12 is the output. So a little bit different arrangement for that. And then you have your connections for the 74, 74, and the 74112, which we'll use later on. Okay, so just make sure when you're building these circuits, you keep this sheet handy, which I have this available in Blackboard for you to use when you start building these. Alright, so once you know what chips you need and the layout, then you can place it on the breadboard like I showed you earlier. Again, putting it across that gap. Being sure that we isolate the left side pins from the right side pins, and then connect our power. So again, pin 7 down here goes to ground, and pin 14 to plus 5 volts. So on the trainer that we are using, you have these posts here for power. So the black one for ground, and the red one, which is our 5 volts, and that's the 2 that you'll be using to connect that. Okay, so remember, every chip that we use has to have power and ground. So if we have 1 or if we have 5 chips, every single one of them will need a connection to ground and 5 volts. Alright, so once you do that, then you can connect your inputs and output. Okay, so here I'm just connecting one output to just use one gate on this chip. So I've ran this blue wire here over to the LEDs to connect our output. So this will indicate the output of the digital circuit. So if we get a green light, that means the output is a logic low. If we get a red light, that means the output is a logic high. Then we can connect our inputs, which are down here at the bottom left of the trainer, which is our logic switches, which are just toggle switches. And there's 2 wires here. Don't know how well you can see those yellow wires coming across to connect to the inputs to the IC chip. Okay, so that's just basically building one gate there to test. All right. So we will add more to this as we go along. Alright, so as you build your circuits, you may find that it doesn't work properly. So to check that, you will want to use a logic probe. Okay, and that is this right here. This is the logic probe. So you'll connect these alligator leads to those terminal posts to get a 5 volt connection to make it work, and then you'll use the tip of the probe here to connect to your circuit to be able to make measurements to see if you're getting a high or low signal. So this will let you test that to see if it's actually doing what it's supposed to. So many times you may have one gate in the chip that's bad. So you can use this logic probe to find that. So you have these indicators here to indicate a high or a low. So you have a selector switch here to pick which type of logic. So we're using TTL. And then you have a memory pulse switch here that you can use to push it up to memory to let it memorize the state in case you're reaching somewhere that you can't see the actual reading of that. Okay? So when you are using the logic probe, you want to make sure that the tip of it connects to the pin as shown here in this picture. So you don't want to connect it to the wire or push it down into the breadboard. You want to actually connect to the pin on the chip so you're getting the most accurate reading. Okay, so here in this picture I've just pulled away a little bit so you can see here that the red light is on to indicate that that is showing a high right now on that pin. Okay, so we can use this to verify that it is working where it's supposed to. So as we build more complicated circuits, combination circuits with many different gates, you can use this to check each gate in the circuit to verify that all parts of it are working, or find out where the issue actually is in the circuit. Okay, so there's a lot more information on Blackboard that I have about TTL logic gates and the circuits and voltage levels, so be sure to check all that information out. Just wanted to do this to give you an idea of how to read the schematics for the logic gates and how to install them to connect them for your lab, so you'll have an idea of how to do that. Alright, so as always, if you have any more questions, let me know, and have a great day. Thank you.